What up, guys? We're back. We are back, Jerry and I, to teach you Swift. This is episode 19. Well, for me to learn Swift, and for you guys to learn along more specifically, given this is a zero engagement stream, but hopefully so helpful. Now, this is episode 19, like I said, and just for the uninitiated, very quickly, obviously we're 19 episodes in as of today, and we did start this from scratch, so if you want to learn Swift or SwiftUI or both, definitely follow along. And yeah, this stream is it's not quite a daily. I miss a little too many days to call it daily, but I would say minimally you can think of it as every other day. So the idea is to go through this literature, which is showing us the Swift language in depth. Then we'll go to SwiftUI. Then we're going to do some app planning for my startup that I've talked about a little bit. And then we'll move into more learning with a focus on iOS programming and macOS programming. So the platform-specific APIs, working closely with those with the same book. And then after that, we're just going to actually build the thing. So follow along, stick around, and just remember that you're going at my pace. Okay, so last time I got the job, by the way. Yeah, so that's good. But yeah, so we were looking at, what were we looking at? Oh yeah, functions that take other functions as arguments. So like func make character remover. Looks normal so far. Nothing we haven't seen. External parameter name, the type. But then on the return type, it's a closure. So this tuple single element string with a return type of string. So that is the signature for the function that this function will return when it's called. And so then you see inside the body, this differs a bit. So we're not just straight up writing the closure, it's naming yet another function. Which that's normal. I mean, that's normal function signature that we've seen. And then we saw this, this was 2 episodes ago, I believe, at this point, but on the return value, this is a method call on input, or really, I mean, map, filter, and reduce are the ones we looked at. So map, filter, and reduce can all be applied to the string type, and a lot more than that as well, like the array type. I think all of them except for, if I'm not mistaken, tuples and booleans. But either way, we'll cover that more in depth. So this is a method call, and then this is that trailing closure syntax, as they called it. So this is just shorthand, but this is telling the filter function how to filter. So if the first character does not equal if it does not equal the character that we feed into it. So then further down, if we look here, so basically we're saying if it doesn't equal H, then return it from the string. And so then we just get the string back with the letter gone, kind of a thing. So that makes sense. But one thing I realized, and that I said before, we're gonna speed it up a little bit, in the sense that we won't stop to do the challenges necessarily, because honestly there's been so much. I think we'll just do one stream at the very end where we do a refresher on each of the concepts and do the challenges then, because I was trying to sit down and do some of this, like, just to see how much Swift I could write, just off the dome, you know, and nothing was really coming to me. I mean, I can remember the things here and there, but not in the sense where I felt like I could actually make something happen. Not like I could with, like, if you told me to write a quick little routine in SQL or in Go, I could do a little something for you. But with Swift, I don't know, there's so much, all the information is kind of just mashed potatoes right now. So we're just going to keep moving through it because it's making sense when we're in it, right? Like when we look at it and do the thing, it makes sense. But with no practical application, yes, as of yet, no practical application as of yet, I'm just finding it kind of difficult. So we're just gonna switch it up a little bit, just so you know and know what to expect. All right. So what was next? Okay, great. That was the end of the chapter. Part 4. We're getting there, guys. This is page 290 of 818, which is wild. And we've already covered, like, just for comparison's sake, what's interesting about the fact that we've covered, you know, that much content and the amount of content. So we've covered, you know, the data types and primitives, string interpolation, functions, conditionals, true, false, control flow. I mean, what's interesting about it is normally, like, obviously page count is not a great indicator because that can, you know, you can change the font size and really impact how many pages. But just generally speaking, I would say, just as a comparison, if you were to go and read, like, basically any Go book, you'll be hard pressed to find one much longer than that, and certainly, like, the whole language is going to fit into that. So it's just kind of interesting. There's simply not as many ways to do things in Go, and I'm telling you that in case, because I know we've done comparisons along the way to Golang in terms of, like, how the syntax compares. And yeah, I don't know. It's just a quick aside. I'm not saying go learn Go now. Obviously, I want you to stay here, learn Swift. But it's just interesting that, I guess it just highlights the fact that Go really has stuck to its guns in terms of simplicity. Like, it intentionally doesn't want a lot of the niceties that we've seen Swift already put on display for purposes of not being so complex and being able to learn it, you know, in a weekend if you already know how to program or something like that. Maybe not in a weekend, that's a bit of a stretch, but anyway, yeah, so that although there are a lot of similarities in programming languages, there's certainly, it becomes obvious when people talk about complexity and big languages. And I would say Swift is a massive language just because there's, you know, all the platforms that get included with it. SwiftUI gets rolled in there, so there's a lot of components to it. But yeah, anyway, so 298.18, and we're really through the core of the language. So I'm interested to see what else. Where are we? We're at, yeah. See, so we've covered conditionals, working with numbers, switch, loops, strings, collections of functions, arrays, optionals, dictionary sets, functions, closures. Now we're getting into enumerations. Ooh, enums. Love me some enums. Structures. If those are like Go structs, then I generally will know what that is. Now classes, I will tell you, I'm not excited for. This is going to be the first. Go doesn't have classes, and I specifically, like, coming from SQL, because of course SQL doesn't have classes, but when I was doing our research, I didn't want to learn a language that had classes. I wanted to stay away from object-oriented as much as I could. So I must admit, I have a little concern when I look at, you know, because obviously I did some research and whatnot, and when I look at, like, SwiftUI, for example, iOS programming, classes are everywhere, and I mean, we'll see. It supposedly Swift supports multiple paradigms, right? So if we don't have to use a lot of classes, hopefully we don't, well, if we don't need to, then we won't have to, in theory, but we'll see if that's true. All right, so let's get into it. Enumeration, structures, and classes, part 4. You'll be defining your own custom types in this part of the book and studying how decisions you make while writing code impact your project later. You'll be adding features to projects and changing them as the projects progress. This is part of this. This is part of writing code for real projects. Yeah, okay. Sometimes you start developing an application with one solution in mind and then have to modify your code when you learn a better pattern or need to accommodate a new or changed feature. This does not mean the first code or tools were bad, just that they would be better for other circumstances. Projects often evolve and develop, and decisions that are ideal at one stage may become inadequate as requirements change. Learning to be flexible in the face of these changes is part of the trade. Yep. Boy, do they. Yeah, I always felt bad for my devs in a past life, because before I was actually writing applications, I was the one writing, interfacing with a customer, and then writing the specification for mods, because we had an in-house product. And then, the customer, 2 weeks into it, let's say it's a 4-week job, developers start working on it, everything makes sense. Now they want to change something. I issue a change to the document, issue it out to the schedule. But can you imagine? That would be incredibly frustrating. If you think about all of the complexity that we're learning here, and you can imagine, sure, you have a team, but our team was small. It was just 2 developers. So whether it's documented or not, in their head, they have to manage and really understand the language at a deep level to make sense of all of the, anything that I say, any business logic that I convey that needs to be created, they have to know what that semantic meaning and how it, they have to know, or wait, what am I trying to say? They have to translate that business requirement to the semantics of the language that they're using. And so that's why I guess for me, it's better to have a more expressive language. So going back to the whole Go comparison, something like Swift would be better for, I think, those fast-paced change. Well, I don't know. I guess it's up to whatever you think. But it just makes me think about that and makes me give those guys kudos, because, that can't be easy. Enumerations. Up to this point, you've been using Swift's built-in types like integers, strings, arrays, and dictionaries. The next 2 chapters will show the capabilities the language provides to create your own types. The focus of this chapter is enumerations, or enums, which allow you to create instances that are one of a defined list of cases. If you have used enumerations in other languages, much of this chapter will be familiar, but Swift's enums also have some advanced features that make them unique. Yeah, enums are just a way to predefine a list, so you don't necessarily want to take just any type of string. You only want to take specific options, they hit a little menu, and then the options are yes, no, I'd rather not say, instead of it just being like an open text box. So that's what enums are for. We use those in SQL a lot for data types. Basic enumerations. Create a new macOS playground called enumerations. All right. It's been a while since we whipped up a new playground, brother. Next. Call it what? Enumerations. Okay. Okay. That's good enough. Okay. You know what's interesting? We still don't know. I vaguely know, but still don't know from the book what the hell cocoa is. Import cocoa. Okay. Enum. Text. Alignment. Open body. Oh, I like this already. Oh, man. Yeah, baby. Oh, yeah. This shit I hate. Like JSON style. What the fuck is this? Why? Just why? Okay, so this I like. Alright, case value. Wait. Oh, I did that. And center. Okay. You define an enumeration with the enum keyword followed by the name of the enumeration. The opening brace opens the body of the enum. It must contain at least one case statement that declares the possible values for the enum. Here you include 3. Left, right, and center, as we see. As an aside, the names of types, including enums, begin with a capital letter by convention. By convention, not requirement. Okay, so text alignment. Yeah, I guess. If multiple words are needed, excuse me, capitalize. Why do I have hiccups? Yeah, I'm yawning. The attack of bodily functions. All right, capitalize the first letter of each word. This is called Pascal case. Pascal cased type. I actually hate this a lot. I really don't like it. That's not any harder to read, and it looks better to me. I don't know, the altering. Oh my gosh, I want to sneeze. Hold on. Oh, you gotta fight it. Once it starts. I took my allergy pill already too. It must be blowing in today. Oh man, I have horrible allergies. St. Augustine, oak tree, which out here in Dallas, those are not great things to be allergic to. They're everywhere. Ragweed too, I think, is the other one. Dandelions, but those aren't. Wow, who knows? Now I'm stuck. God damn it. Okay, hold on. Oh wait, here we go. Okay, sorry about that. Now then, wait, case center. Why isn't that? Expected identifier. Oh right, I was jacking around with that. My bad. Now it'll run. Make that a little wider. No, Xcode, you don't want to do it? Couldn't create workspace. What, bro? What are you talking about? Ah, yeah. Hold on, let me. Gotta love Justin Chapman. Well, whatever. I got a job. So, all right. So then let's restart Xcode. I am interested, really and truly, to see what it's like to code in Xcode, like actually just working in it day to day. Just because. Not always, but a lot of times, people will just things are just overblown, you know, a lot of times. And normally it's the case that if something is even semi-popular, you know, Alright. God dang it. I just did it again, didn't I? I did. Son of a bitch. Hold on one sec. I just showed my AI key. I gotta go. in the event that someone is actually watching and or sees this, I couldn't possibly leave it up, so I gotta go out of my way. I'm such a dummy. My apologies. OpenAI. Hold on one sec. My girlfriend's in there singing, and it's beautiful. Oh man. Okay. Where did it go? View user API keys. Okay, it was probably that one. Now, if I'm smart about it, I won't put it in that same spot. Let's just put it here. Private. Here we go, brother. Oh, I'll have to show you guys this app. It's really cool. Actually, I've showed it before, but I didn't show you a particular feature. And I need to use it more, but that's not the point right now. Test. Good to go. Okay. All right, bringing you guys back. Learnalong. There you are. Okay. Now that we're back here, this doesn't show my key, does it? That'd be stupid. Okay. Xcode. Why won't it? All right, enumerations. And all right, much better. Hopefully it will run now and everything will be good. Why am I not getting any feedback from it? What the hell? Enumeration, you don't have permission to. Bro. I think that went away though last time. Let me just try to do a quick save. Okay, it went away. No, it didn't. Folder saying no. Okay. Why, brother? Please help me fix this. How can I resolve this? Same one I've been writing to, change permissions. I mean, that won't hurt. I don't know why they would have changed, but relocate project, check disk integrity. Oh wait, yeah, what's it? That is the wrong file, okay. I don't know how it got. Weird, that's the old one. Alright, my bad. Shucks. Now let's just okay. Is that better? See, he does weird shit like that disc. It did exist at one point, but I mean, it's been months since it was named that. And it's been changed since. I don't know. iCloud does some whatever it wants sometimes. I don't know how else it would have changed. Are you running it? What are you doing? Come on, brother. I'm gonna have to restart, Jared. I don't know why it's doing that. Yeah, I don't know. Luckily, we're streaming from a different machine, so that's the beauty of that. Now we get nice little Elgato. What y'all know about Elgato? Yeah, hopefully this is not a reflection on the general experience working in Xcode. I will say this though, just kind of random, but it's on my mind. So I got a MacBook Pro, the 16. It's only 16 gigs of RAM, the M2 Pro chip, and it's not a bad machine by any stretch, but this whole notion that, like, because I've heard this said before, like a 8 gig Well, I'm saying this in the context of, because a lot of people have the question, I had the question, is 8 and or 16 gigs enough for a dev machine? Like if you want to get a Mac and you want to, you want to write for the Apple platforms, is that enough? Now, I think on the one hand, I think 16 is definitely enough. I don't think 8 is enough. You can do it on 8, but I don't think you'll have a good time, is my thing. So if you can possibly afford 16, I would say go 16. But I still feel like, it's not going to, this is another, fucking Max, dude. It won't just start up. I got to open the lid because it's, I don't know, it's Mac OS. Hold on one second. See, guys? Macs are so easy to work with. Apple stuff, it just works. It's so easy. That's how we've been able to just move right along on this stream. It's how we're so productive. That's my secret weapon. I always get asked, brother, how do you do it? How do you stay so productive? I just say, well, brother, shit got a Mac. Right? That's the truth, right? Yep, of course. Of course. All right, so then sarcastic hate aside, let's just be literal. I don't like macOS. Did I say I was curious earlier what it'd be like to work in Xcode all the time? I meant... What I meant to say was I'm a lunatic for voluntarily buying this thing. Okay. But it is what it is, and we're here now. So now, will it work? But yeah, on the Macs, like if you use it as if you have it in clamshell mode, I just have mine in a little stand. I'm using a single monitor, and you can't do multi-monitor on the Mac unless the power cord is plugged in. And for whatever reason, when you do a reboot, if you have a hub that's plugged in, you gotta unplug the hub. It doesn't just recognize shit. This is Apple's hub, USB hub. I don't fucking know. And what's it doing? It's still not. Maybe it doesn't show me anything. I don't know. Maybe it's not supposed to, but it looks like it's trying to do something. Yeah, maybe it just doesn't do anything. We'll hope that's the reason and just get on with it. Command Shift Y. Oh, I did switch that. Oh, that's right. Okay. So Control. Make that Alt. Y. Okay. All right, let's just see. Hopefully that's just, I don't know what it's doing, whatever it's doing. You define an enumeration with the enum keyword followed by the name. Oh, wait, body read that. Yeah, Pascal case. The name of the enumeration here, text alignment, is now usable as a type. The name of the enumeration. Oh, that's interesting. Just like int or string, or the various other types that have various other types you have used so far. That means you can now create instances of that type. Is that? I guess one good thing, the text looks different but better. That's one upside. I like to look on the upside. If that's what I gotta reach for, I'll do it. Var alignment. Oh, I see. Yeah. Is equal to text alignment method call left. Okay, so I guess enum just didn't give you anything. That's weird. I thought it would have, but that is okay. Type of. Oh, I thought that was a global function. Okay, whatever. Doesn't matter. Okay, so what do you want me to do? So left, what do we do? You can now create instance of that type. Var alignment, text alignment. Oh, okay, so the dot is just whatever. So if we did like case booty, and then okay, I like that. That's cool. But what case text line? Okay, yeah, I'm trying to think of how I might use that, but yeah, what would be cool, I'm not sure if this would be a good application for it or not yet, but just thinking if we can expose these case values, so left, right, center, those could just as easily be like relative time periods on a criteria screen for data. So like yesterday, last week, last year, you know, relative dates, which I'll definitely make a lot of use of. So wait, what do we get error down here? Cannot find type of. Oh, that was from earlier. Okay. All right. Yeah, so that sounds like it would fit. Although text alignment is a type that you've defined, the compiler can still infer the type for alignment. Therefore, you can omit the explicit type of the alignment variable. Okay. Taking advantage of type inference. The compiler's ability to infer the type of enumerations is not limited to, goddamn sneezes, is not limited to variable declarations. If you have a variable known to be of a particular enum type, you can omit the type from the case statement when assigning a new value to the variable. Just trying to be patriotic, guys, but I'll have to go with happy blanket for now. Brr. So weird, like 68 is just a little too cold. 69 gets too hot for me. Sometimes I'll do sweats and a tank top, and that's kind of a good balance, but that's more like for couchy stuff. But if at the desk, maybe I should do hoodie shorts. 68, I'm still figuring out this place, but yeah. Okay, so the compiler. Oh, I see. So they're just saying, yeah, through the power of inference, we do not need explicit type annotation, and it can still sort it out. Interesting though that it gives us the dot left. Why dot left? The compiler's ability to infer the type of enumerations is not limited to variable declarations. If you have a variable, we run that, inferring the enum type. Okay, so var alignment, text alignment left, and alignment is equal to dot right. So alignment is equal to text alignment left, and then I reassign it to dot right. Oh, I see. So okay, it's saying that it knows that the case statement inside the enum dot right is valid, so I don't have to call text, or I don't have to declare text alignment. Okay. Okay. You have to specify the enum's type and value when initially creating the alignment variable, because that line gives alignment. You have to specify the enum's type and value, yes, when initially creating the alignment variable, because that line gives alignment, both its type, which its type is text alignment, And god dang it. I forgot what the Mac OS emoji control command space. It's not working. Well, whatever. Man, this thing is just command. Yeah, don't show this. Nothing's fucking working today, dude. Now my app. Oh my goodness. Okay, well. Look at that. I will be right back. All I was trying to do was get my fucking emoji menu to come up. But we're going ghetto today. What did that do? Okay, be right back. Jeez. Okay, I'm sure you're all gone by now, but things have been settled. That's good. I guess all systems, biological or otherwise, are just going haywire today. TMI, but we're all good now. Okay, so, what a day. We're gonna learn something. Shit. Just gotta suffer through. Alright. What now is that still? Okay, we're good. Now then. 2 years later. Where were we? Oh. You have to specify the enum. No, we did that. No, we didn't. You have to specify the enum's type and value when initially creating the alignment variable, because that line gives alignment both its type and its value. In the next line, you can omit the type and simply reassign alignment to a different value within its type. You can also omit the enum type when passing its values to functions or comparing them. Okay. So if alignment. Oh, now my other thing's working now too. Great. Equality operator. So if it's equal to right, then do this thing. Print. We should right align the text. Okay. While enum values can be compared in if statements, switch statements are typically used to handle enum values. Use switch to print the alignment in a more human readable way. Oh my goodness. Okay. In a more human readable way. I find this rather readable, but I will comply. Switch. Oops. Case left. Oh yeah, I remember these. Yeah, these are nice. Whoops. Lowercase left aligned. Left aligned. If right, print. And case center. Recall from chapter 5 that all switch statements must be exhaustive. Alright, either handle all cases or have a default. Some of the switch statements you wrote in that chapter required a default case to meet that requirement. When switching on enumeration values, the compiler knows all possible values of the enumeration to check. Cool. If you include a case for each one, the switch is exhaustive and no default case is necessary. You could include a default case when switching on an enum type. So instead of... Oh, okay. Okay. Oops. Default. Okay. This code works, but we recommend avoiding default clauses when switching on enum types because using a default is not as future-proof. Right, because you might modify it. Yep, suppose for example you add another alignment option for justified text. Okay. Justify. Yep, and now that code would be broken. Listing var alignment. Oh, so no longer left, now justify. You want me to get rid of this? Your program still runs, but it now prints the wrong value. Oh, it does? Oh wait, what did I do? Switch alignment. Justify. Oh, I see. Yeah. So we make it equals to justify here, but because of the way we wrote the switch statement initially, since it doesn't equal left or right, it takes the default and it says centered, but that is not correct because we can see clearly that it's justify. Okay. Your program's to run now prints the wrong value. The alignment variable is set to justify, but the switch statement prints center align. This is what we mean when we say using a default not as future-proof. It adds complication to modifying your code in the future. Change your switch back to listing each case explicitly. Oh, whoops. Center. But don't add justify, or they didn't. Okay. Now instead of your program running and printing the wrong answer, you have a compile time error that your switch statement is not exhaustive. Okay, so they're showing us. It may seem odd to say that a compiler error is desirable, but that is exactly the situation here. Right, because you don't want to let loose a switch statement on an enum in an incomplete fashion. That wouldn't make any sense. Otherwise, it wouldn't be a part of the enum. So, if you use a default clause when switching on an enum, your switch statement will always be exhaustive and satisfy the compiler. If you add a new case to the enum without updating the switch statement will use the default case when it encounters the new case. Right, as we just saw. So they're just re-explaining. Your code will compile, but it might not do what you intended. By listing each enum case in the switch, you ensure the compiler will help you find all the places in your code that must be updated if you add cases to your enum. That is what is happening here. The compiler is telling you that your switch statement does not include all the cases defined in your enum. Go ahead and fix that. Okay. Case justify. Oh, just justify. That makes a little more sense. What would happen? So I'm using this app, so like my mouse and keyboard are actually plugged into my Windows machine that is also my streaming machine, and I'm just feeding the Mac's video input into a capture card. And so this app lets me like I have my laptop on my left, the Windows laptop. We're seeing my Mac screen. So I can just seamlessly go left to right with the same mouse from Windows to Mac as if I was just using, two monitors on a single machine. So it's really cool. But that was every now and again it'll stutter and lag, or I'll just lose my cursor altogether and it'll reset to the Windows machine. I have to drag it back. But that's why I brought up the RAM. I mean, it's annoying that I'm even remotely having issues right now. Basically just saying I regret not getting the 32, honestly. Even though I'm just like really disenchanted with macOS, period. But it's a necessity to write apps for it, so I mean, I know you can do like some virtual stuff or a Hackintosh, but that's, to me, even worse. You'll just waste more time. But so I don't need that open. But yeah, it's frustrating because on my Windows machine, this says 64 gigs of memory. I can run Docker and 2 VMs and a couple SQL servers, and I can do all kinds of stuff, and it never breaks a sweat. But I was hoping it was true that the 16 gig on the on Mac, with Apple Silicon, because this is the M2 Pro. I was hoping at least some of the marketing hype was true. They say like 16, or I think they try to pass it off as like an 8 gig M2, for example. 8 gigs of memory with an M2 would be the equivalent of a 16 gig or 24 gig Windows machine. Bullshit. Nope. Feels about the same to me. Yep. Well, meaning like gig for gig, Windows to Mac, just in terms of like anecdotally with the amount of apps I can run concurrently. Yeah, no, I don't see that benefit like at all. I don't buy that at all. Yeah, so don't do what I did. Just save and then buy at least a 32 gig something, but don't get anything less, honestly, unless you're only going to use it like strictly literally nothing else other than dev. But you won't, because that's what I told myself, because I bought this Mac only because I found it brand new secondhand. So like some chick was selling it, she got it as a gift, wanted the cash, was just trying to sell it because she already had an older one, but she had no desire to, she didn't need to upgrade, so she just wanted some cash. So it was a really good deal. I was just hopeful the specs would line up with that good deal. But yeah, I'm probably going to end up getting a Mac Studio, honestly. Just sell this one, take the hit, and get the Mac Studio with 32. Man, live and learn. Oh well. All right, so enumeration with raw value, blah, 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 text. So we did that. Case justify. Where were we? I was lost in my hate for, okay, enumerations with raw values. Did I skip over? How do we get here? Print left, center. No, we did. Case justify. Oh, right, it was here. That's when I lost the cursor. Okay, justify. Okay. Now the compiler is satisfied. Yeah. Enumerations with raw values. If you have used enumerations in a language like C or C++, you may be surprised to learn that Swift enums do not have an underlying integer type. I'm not, but yeah, I haven't worked with those languages in that manner. But you can get the same behavior by using what Swift calls a raw value. To use int raw values for your text alignment enumeration, change the declaration of the enum. Enum text alignment int. See, it happened again. Fucking this. Not happy right now. Int. I'm blessed though. I shouldn't complain. It's fixable, so I won't complain. To use any more than I already have. To use int raw values for your text alignment. Okay, we changed that. Okay, so you can treat it weird. All right, so I thought that was a type, but now. Weird, yeah, okay. So what? What is it then? To use int raw values. Specifying a raw value type for text alignment gives a distinct raw value of that type to each case. Okay. So then left, right, center, and justify would have to be represented by integer values. Like 0, 1, 2, 3 or something like that. The default behavior for integer raw values is that the first case gets a raw value of 0. Yep. Yeah, good old 0 indexing. Knew that was coming. I'm gonna play a video for y'all at the end of this stream about this topic here that I thought it was a good video that I would like for you guys to see, because I think it's important to kind of highlight why we're seeing this still and how it's annoying, but we'll get back to that. Okay, so alright, so for now we're treating it as though it is or we're treating it just like arrays, even though it's an enum, meaning we're using the 0 index, so 0, 1, 2, 3. Okay, if we apply the raw int value. The default behavior for integer raw values is the first case gets raw value 0, the next case gets raw value 1, and so on. Confirm this by printing some interpolated strings. Okay, I'll do it. Text alignment, dot left, dot, yeah, cool. How do I, y, and down, p, j, p, okay. Capital A to go to the end of the line. Right, center, center, justify, and align that raw value. Yep, so left being first in our, or not the switch, sorry. Left being the first case value gets raw value 0, and subsequently increment by 1 for the rest. 1, 2, 3. You are not limited to the default behavior for raw values. If you prefer, you can specify the raw value for each case. Oh, in the declaration you can, oh, I like that. Okay, good. So you don't have to do that goofy from 0. Yeah, because, yeah, I mean, the general point is, like the video I wanted you guys to watch, it's just talking about how that behavior, which really should only apply to arrays, we let that bleed. Or rather, it really only kind of makes sense with arrays because that's just how it was done. So 0-based indexing just kind of caught on. But more often than not, when you're encountering it in other places, like here in an enum with raw values, it would make more sense to start the first value as just 1, 2, 3, 4, you know, if you're going to reference them. But that's the general consensus. That's basically it. But it's just an exercise in, or it goes to show, like, we can just keep on doing things just because, and if no one questions it, it just becomes a thing, you know. But yeah, just a thinking exercise. But some languages don't do that, like Lua. So they are out there, just FYI. Which is even more annoying because you just kind of, it's just another thing to be very aware of. All right, so using raw values, so we can, oh right, so we can specify them. He made that 20, 30. 40. Pull up from 40. Don't worry, that you can try that key now and it won't work. Actually, while I'm here. But yeah, try your heart out, little guy. Alright, Xcode. Raw value, version. And then, there we go, 50. Go figure. 50. When are raw values in an enumeration useful? Question mark. The most common reason for using raw values is to store or transmit the enum to a system that does not know about your text alignment type. The most common reason for using raw values is to store or transmit. Right. Store or transmit the enum to a system that does not know about your text alignment type. That's interesting. I'm just gonna highlight that. Sounds like a good food for thought with respect to building APIs and stuff like that. Ooh, I could use that to tie it to like a GraphQL implementation. Yeah. All right, instead of writing functions to transform a variable holding an enum, you can use raw value to convert the variable to its raw value. Oh, okay. So that'll be 50 if I rerun this. Yeah. Yeah, okay. I like that. Instead of writing function, wait. This brings up another question. If you have a raw value, how do you convert it back to the enum type? Every enum type with a raw value can be created with a raw value argument. Every enum type with a raw value can be created, which returns an optional enum. What? If you have... Yeah, just show me. Why would you go the other way with it? I don't get that. Converting raw values to enum types. Okay. Create a raw value. Let, so constant. Create a constant called my raw value. The value of 20. Okay. Into a if let my alignment if let my alignment equal text alignment where am I at? Text alignment raw value, my raw value. It's gonna bother me. Convert. Okay. I forget what they called these if let. Temporary something like that. Conversion. spelled right? Succeeded. 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 Yeah. Okay. Print. Successfully created escape character. Alignment. My raw value. Put oh, it just looks funny because it's small. Okay, then here. Close that. That looks weird. Else. Failed. There's no corresponding. Okay, but what's happening? I guess I don't understand when you would use this. Going the other way with it. You start with maybe like on key submission to unlock modules. Yeah. You start with the my raw value, a variable of type int, R20 here. Then you try to convert that raw value into a text alignment case using text alignment raw value. Because text alignment raw value has a return type of text alignment optional, you use optional binding. Optional binding, that's what. Yeah. You use optional binding to determine whether you get a text alignment value or nil back. Okay, I mean, that makes sense to me. The raw value you used here corresponds to text alignment dot left. So the conversion succeeds. Try changing my raw value to a raw value that does not exist to see the message that conversion is not possible. Okay. How about 200? And we get it. 200 has no corresponding text alignment case. Okay. So far you've been using int as the type for your raw values. Swift also allows raw values to be strings, characters, or instances of any numeric type. Or instances of any numeric type. Good. Yep. Create a new enum. Create a new enum that uses string as its raw value type. case Swift equal Swift. C equals C. Java. Java is grotesque to look at. Let my favorite language equal programming dot Swift. Okay. Print. Programming language is SQL. Language dot raw value. I see what you're doing. Very, very clever. Yep. Here you specify a corresponding raw string value for each case. However, just as compiler will automatically provide integer values, if you do not set them yourself, it will automatically use the name of a case as its string raw value. However, just as the compiler will automatically provide integer raw values, if you do not set them yourself, it will automatically use the name of a case as its string raw value. So once you have declared that an enum has string raw values, you do not need to assign values if they match the case names. That's good, and I just lost my cursor again. We're gonna cut it there, y'all, because this, I really do want to go and just get a decent Mac that's not gonna stutter. This is really pissing me off. What a joke. I'm really annoyed, but blessed. Apologies for the technical difficulties, but we must carry on. We will carry on. But for now, we're gonna wrap it up. I feel like I learned a little bit of something eventually through all that. Thanks for tuning in. We'll be back tomorrow. We will actually be back tomorrow, because now I'm motivated to go fix this machine situation. Yeah. And once I have that resolved, that'll just generally make streaming easier anyway. But yeah, it's really frustrating. Don't buy a 16 gig anything. I don't care what it is. Not if you want to be a dev. Alright, so thanks for watching, guys. Tune in tonight for the Halo stream, if you're into that. 11 o'clock CST. Or sorry, 9 p.m. CST. Till about 11. Maybe later, if we're killing. Or if I'm dookie trash, I might get off earlier. But yeah, other than that, guys, thanks for tuning in. And let me flash the, make sure you follow me everywhere. Donate, money order, Western Union, okay, Kickstarter, all that, Patreon. All right, guys, be loved and give love. Good day to you.